people that are here, hello, I'm Jose Cortines. I've shown up at a couple of these. I've done Ruby for like 10 years. I've been doing GraphQL like in my spare time because I believe in it. It's awesome. And I've been doing a lot of React because of that, and like as alongside of that. Let's put it that way. So I committed to this talk like a month ago, and I started writing the slides today, and it is awesome. Right? If you could please pass me my beer, sir. So the idea is it's a talk about replacing REST APIs with GraphQL, right? That's the title that I made up when I committed to this, and that's what we're going to stick with. Now, we're going to talk a kind of a high-level overview about an API that I made, just like a kind of a hypothetical API. I actually made the app so we can look at it. It's got a front end, like it's got like HTML portion to it, things like that. And we're going to discuss how fast can we make a GraphQL API to query this data model, and then could we build a React Native application also to query that GraphQL API. And along the way, we're going to look at like querying the API directly using graphical, things like that. We're going to talk about things like that. So replacing REST with GraphQL, a story of GraphQL, Ruby, React Native, and Apollo, right? Who knows if we'll get to it all, but let's see. So we start with the to-do app. No, I'm just kidding. All right, let's start with something, everyone does that. Let's start with something slightly more realistic. We start with something that's like Reddit, okay? Things you can do on this app. You can view a list of posts. You can view the post details. You can upvote and downvote posts, which I did in just the jankiest, ugliest way right now. You can view user details and the posts that those users have made. Now, in terms of what the actual app looks like, I mean, it's got a user model, it's got a post model, it's got a comment model, it's got a vote model. I seeded it with like 10 users, and then those users are the authors of like 40 posts, right? So there's like a little data model that already exists. It's really ugly, right? That's what it looks like right now. There's zero styling. It's just straight HTML, but it works. And we can look at it where we will look at it more directly in a little while. That's like a post show page. It's like very standard Rails stuff because it was really fast to make. So then we look at like, let's say like the post controller. Post controller is very standard. These are 3 actions in the post controller. This is like vanilla Rails, as vanilla as it gets. We're including a user because when we're rendering, we want to, we want to bring in the user so that we don't do n+1 queries every time that we render the user's username, for example, next to a post. This is the bottom half of that same controller. You have a normal create action, and then I have this kind of non-RESTful action called upvote, where essentially you find a post and then you call post.upvote, which does some database stuff in the background. It could be better, but what it does is it deletes any votes you've made, and then it just recreates them in the direction that you wanted to make. So if you had an upvote and now you're downvoting the thing, it deletes all your upvotes and then it creates a downvote. And then vote scoring itself is calculated by taking the -1s and +1s essentially that exist on every vote record, and then just reducing down on those. And you can say, okay, so if 3 vote records exist that are +1, and then 1 vote record exists that's a -1, and then you reduce that across, you basically sum that over 0 in a reducer, you end up with a score of 2, for example, right? So what do we do in the case of an API needing to exist for this resource? So we have like a post resource. We know that we have the HTML front end for this. Boom, localhost. We're going to 3000. There it is. It's really ugly. But it looks almost as good as Reddit was when it started.
Looks like Craigslist.
Yes, exactly. Right, it's vanilla HTML. You have all this stuff. You have, let's see, this one has a -1, but if I upvote it, now it's got a 1. Things like that. If you went to a specific post URL, you can see that the post's content is there. If you go to a user, you can see all of the posts that user has made. For example, these are all the things that they've authored. Simple. Like the data model is this little graph of data, essentially. You could start from a post, and you could say, okay, the user, the author of that post, what posts have they made? You can start to kind of query deeper into the graph. But that kind of stuff is not easy to do in a RESTful API. When you think about it, when you're thinking about a RESTful API, you might return a list of post JSON. And then that post JSON maybe has a user ID, or that post JSON maybe has a user bit of JSON embedded inside of it under user. right? And then what happens when you want to get to that user's post? Well, then you have to make another request for maybe that user's details, things like that. It's painful when you have to deal with nested data, when you have to deal with trying to query deeply into nested data. So that's something that GraphQL kind of solves. And so we're going to get back to the Prezo. Right. So here we go. All right. So a pretty normal thing is to define API-specific controllers, or even just to use the automatic formatting rendering provided by Rails. So in the case of a post, for example, you can literally, and I did this, you can put a post.json.jbuilder file in the same directory as the original post, like the post.html stuff. And then when it's requested using the JSON format, well, those files are rendered instead, and you get JSON back instead of a post. And that's exactly what I did to make the initial kind of ugly RESTful API for this, and we can query it and check it out. So what does it look like when you rely on the formatting, on like automatic Rails formatting to render JSON, for example, right? So this file is app views post.json.jbuilder, right? It's just a JBuilder thing. What that's doing is it's extracting from a post object the ID, the title, the description, and the score being a method on that object, on an instance method. And it puts that in a JSON object. And then we're also rendering a sub object. In this case, we're rendering a partial that is the user of that, of that post. I think there's a typo here in the sense that the user is not nested under user. I think it's just being directly inserted, but no bother. It's not a big deal. So when a request is made for the JSON of a post, we return it and it's all good, right? Notice though, there's a line that specifies that we render a user with every single post. So there, in this case, there's a nested user object inside of every single post. Every time you request a post using JSON from this API, you're going to also get a user. But do we always need that data? It's not for you to decide. It's up to the API consumer to decide, to do what they need to do with your API response. Different interfaces are going to require different shapes of data. Requirements are going to change. Old versions of your app might exist for a long time if you built an app, or if you did some kind of progressive web app, or so many other things. Some people have literally different versions that they need to support across enterprises, things like that. So how quickly can we create a GraphQL API to query all this same data, right? So first thing we're going to do is we're going to look at the RESTful API that kind of exists, and then we're going to look at a GraphQL API that I built on top of this data model. And then we're going to query around, and we're going to see all the kind of cool queries we can do. We're going to look at mutations, and then we're going to get into some more interesting live coding where, for example, we're going to build pagination into getting posts. Right now, when posts are queried, you just get all of them. There's 40 of them, but there could be a gazillion. There could be an infinity, right? So you want to be able to paginate across that. We're going to look at mutations, and maybe we'll add a mutation for creating a comment, for example, which doesn't exist currently. So let's get into my super on the fly live coding. Here we go. So I'm going to mirror my screen instead of just doing this.
Yeah, no mistake. You can grab a pizza if you want to while you're.
Yeah.
I know you want to get your food.
I'll do it right now. So how do I do this? Jump.
Yeah, do you want mushroom?
I'm good right now, guys.
Okay.
Mirror display. There we go. Okay. So you see everything I'm seeing? Cool. And I'll stay at this resolution. Yeah, which is best for that monitor. Okay. So this might be tiny. I think it is. Let's adjust. So one of the things that I was working on at the last second before I left the house was starting a React Native application that will query this API and display the posts that we were just in the HTML. So we'll look at the HTML first. And let's scale to 1080p. Hey, that's a lot nicer. Okay. All right. So first things first. Let's not do that. Oh. yeah. We'll all be here for a while longer. So we're going to look at host 3000 again. We'll see, here's the list of posts. It's all good. If we do the same, let's say do post.to.json. I think that will give us the JSON output. Yeah, it's really nice. There was that typo in my user stuff, so we will fix that right now. And let's make all this much bigger. And these are actually my slides that I just presented with. I was using Spectacle. But let's look at the post.json.json. So I should have put this inside of user. And there we go. Now let's query it again. There it is. So user, you get the ID, the username, but in much more complex APIs, let's look at like GitHub, for example, right? They have maybe 40 different fields that you can get, and you don't always need all those fields. And the solution used to be that you would add like a fields query parameter that would let you then slice and specify which kind of fields you wanted, but that was extremely painful. And it has been painful like that for a very long time. Then you have to deal with the fact that if you have a lot of associated objects, do you always nest them? Do you use some kind of standard that you only get IDs for those objects and then therefore have to generate your own links? Well, link generation was something that was really painful for a lot of people because they would start to hard code URLs into their API clients, for example. And so that never worked. So then the standard that came after that was to literally return URLs for other API endpoints in API responses. So that there was no URL generation, but you were grabbing URLs out of API responses and then saying, okay, go to this to find that associated data. So then let's look at what a graphical or what a GraphQL schema looks like for all this.
And all those are bad, by the way.
They're all terrible.
Painful.
Yeah.
It's awful.
So let's start with like the user model. For example, the user model is really simple. In terms of other fields that it has a username and it has an email. But we can just ignore the email for now. And then it has this associated data. And these other models have a belongs to coming back to the user. So it's pretty simple. So then let's look at what a GraphQL object type looks like for one of those. And what we're doing here is we're using the GraphQL Ruby library. It's GraphQL-Ruby. But you actually just installed it. It's the gem GraphQL. So you have to define your types when you start using GraphQL. You have to define what types you're going to use, and then you provide metadata on those types. And then you can start to introspect the API itself to like what fields are available on those types, whether certain fields are deprecated, what other types are connected to these fields, et cetera, et cetera. So in this particular case, we're saying that this object type, its name is user, it has a description, it has an ID field, and the not in this case is an operator is overriding an operator essentially that makes it so that it's required. But that's not that important here. So we say it's a type ID, we say a username, it's a type string. Then we say it has posts, and we say it's a type's post type. And types in this case is going to specify an array, so it's a collection of stuff. It's a list of post types, a list of comment types. So we go to post type, another model essentially that we're defining a GraphQL type for. Is it big enough?
Yeah. It can be a little bit bigger.
Ooh. How's that? All right. So we go to post type, another GraphQL model, another model that we're defining a GraphQL object type for. It has an ID, a title, URL, a description, a score. Interesting thing here is score is an instance method on that type. So that's something that is going to be kind of implicitly connected. It's going to look to see if the object post responds to score, and if it does, then it's going to send a message and say, give me whatever the result is of that. Then in the case of author, it has a user, not an author. So we want to override how this field is resolved. And this is the magic of kind of GraphQL, is that as you define your types, you also define how the fields of those types get resolved. It could be anything. Technically, within this block, like the object itself, which is this thing that I'm trying to resolve fields for, I can take the args, which are any arguments that were passed into the initial GraphQL query, and we'll talk about that. And then the context would be an object that I carry around with me that defines more of what's happening around me. In this case, context contains the current user. So whoever's authenticated is passing it within context. So you can do resolutions for fields based on a dynamic current user or a dynamic set of permissions or whatever you want, really. It's completely open. So we're saying that the author is of a user type. And then in this block right here, so this proc, and I'm using a font that has ligatures. So technically this is like bam, bam, but it makes it nice. We're saying object.user. And so object in this case is the post that I'm trying to resolve field for. Same with comments. We're saying object.comments, just to be explicit. And that's a lot more of the same stuff, right? We say, give me the post, give me the user, but it's called author in the GraphQL type. Get to the important thing here. So when you define a GraphQL schema, the GraphQL schema has a couple of expected root types. And those root type, one is called the query root, and the other one is called the mutation root. And coming into play is something that's called the subscription root as well, but that's not something we're going to really talk about here. So the query root defines what queries are available for me to query within my GraphQL graph at the very top level. And so once you start querying at the top level, you can kind of go into subtypes and go further down, deeper and deeper. And you can actually go deeply nested, right? So I have a post, and then I can get the users of that post, like the author. And then that author is going to have posts, and it could be even recursive in this case, right? That author is going to have posts. And then I could say, of those posts, give me the author. And then of that author, give me the post. And you can just keep going forever. But you can limit the complexity and the recursiveness of your queries, the query depth, essentially, so that you don't end up in situations where someone can query for infinite data, right? So that's not really an issue. There's always kind of a default limit. It's not a big deal. So in this case, we say that at the query root, so this is at the very top level of my GraphQL schema, I can query for something called posts, right? And that's an array of post types. And this is the place where we're going to want to have to add pagination, because it's just saying all of them, right? And when it gets all of those posts, what it's going to do, this library in particular, what it does is it iterates through all these posts, and it instantiates a GraphQL post object type. So it maps through them all, and it turns them back into the GraphQL objects that you're expected to return from the GraphQL API. So you're getting models, it's turning them into GraphQL objects, right? Object types of that model. There's a way to query for a single post. And in this case, we say that we expect an argument in our query that's an ID, right? And it's going to resolve to post find args ID. And you can see how the arguments here map to this args parent block, to the resolution block. We'll query for a single user, and we'll be doing that by username. So going kind of deeper, let's actually query this right now. So if we go to graphical on this server, right, and that's mapped at graphical, what we have here is we have the graphical user interface. So GraphQL is a set of specifications, and those specifications are a white paper. They're set in stone in the sense that GraphQL queries should always look a certain way, and APIs should always respond to certain kinds of queries, and those queries are known as introspection queries. So one of the things that the graphical UI does immediately when you open it up is it sends an introspection query to your own server. And that introspection query, we can actually look at it. It's in the logs. I'll make this bigger. Looks like, wow, it's gross. It is. We can grab this. Something like echo. I'm gonna need to, yeah, screw it. It's fine. So it's sending a query, and it's calling it the introspection query, and it's saying basically, give me the schema, and then within the schema, give me the different types of queries there are, the query types, and the name of that query type. Give me the mutation types, give me the subscription types, and then within those, it's going to ask for the name of the field, the description of the field, created around fields and types without actually needing to know anything about the type. It's just getting data about the object. It's think like Java type. The compiler is able to get and discern a lot of information about the data itself ahead of time without you actually need to do anything to the data yet. And so it's able to create these docs. And essentially, this is the schema that we created. We're able to look at it and we say, okay, show me the queries. Okay, these are the queries that are available on this API. And this graphical editor could, for example, be pointed at GitHub's API or Shopify's GraphQL API or any other GraphQL API that exists. And you're going to get docs out of it because everything always responds to introspection queries. It's important that that happens. It's important that it's standardized like that. So it was able to query our query structure, our data structure, our object structure, essentially. And we're able to see that we can send it a post query, and that post query expects an argument of ID, and it's going to return a post type. And a post type has these fields. And these are the fields that we specified. And so if we wanted to start sending some queries, for example, we could say query, we could say query, and we'll say, and this is cool because it already knows a lot about our objects. So it's able to give us, what is it called? Auto completion. Yeah, so we say we can either get a post or posts, and we'll say, let's get posts. And of all the posts, we'll get the ID, and we'll get the title. And what we're doing here is we're composing a GraphQL query. Query has a very specific structure. It's meant to look like this. It's not meant to necessarily be JSON. It's not necessarily meant to be JavaScript. It's its own language. It's like SQL. It's its own query language. And the interesting thing about this, though, is that the shape of the query will always match the shape of the data you get back. So if we say, give us the IDs and the titles, it just hit our GraphQL endpoint, and it was able to return IDs and titles for all this data. Now, let's say I'm working on the interface, and it's like, oh, man, you know what? It turns out that they all need descriptions. Well, okay, let's also get the descriptions, right? We run that. We also get all the descriptions. There's nothing in the API that I wrote that I necessarily have to do that handles or that handles didn't request. And going even further, fields themselves could take arguments. So for example, this description field, if I wanted it to, it could take an argument that tells it how long of a description to give me. I could tell it to truncate at 30 characters, at 40 characters, et cetera, et cetera. And it's completely dynamic because rather than just satisfying, the best way to put it is like APIs of before GraphQL, you just asked for a static key. You said, give me all the things at this URL. But there was no way for it to kind of figure out how to dive deeper into that data to give you exactly what you needed or to give you a dynamic response based on what you needed. And the only way you could really do that was through query parameters and things like that, because that's what's defined in REST. It's painful for developers. It's painful for future-proofing your application or trying to support a lot of different UIs, things like that. So in this case, we have the title and description. Let's also say we want the author. We want the author. This is a subtype. It's a user type. So of that user type, we can get the user's ID, and we can also get the user's username. Now, every single post has an author and an ID. I mean, we don't need all this data, right? We could just say we want an ID. We could just say we only want a username, et cetera, right? Now that we have a username, though, let's say Merle, right? I used Baker. It just made a bunch of data. It was fun. So let's make another query here. And this query, we're going to ask for a specific user. And we know that we're passing the query that we defined at the top. It was specified that it takes a username argument. It's already auto-completing for us that this needs to be a string. Okay. So we'll say username, and we'll pass in Merle. And we will say we want that person's ID, and we want their username, and we want all of their posts. And let's say ID and title of those posts. And we'll send that query. And there it all is. Now, the most interesting thing about this is it's always hitting the same endpoint. It's never had to go to another URL. It's never had to do extra queries to get extra data. It's never had to do anything else other than accept these queries and these arguments and return data. Now, this is what happens when you do your resolutions naively, right? And you don't necessarily do any kind of batching of your resolutions, but that is easily remedied. Just like with Rails, you can preload data as you're trying to kind of like render it. You can do the same thing with your GraphQL queries in the sense that resolved your queries, you could start to batch together what IDs you're trying to resolve for users, for example. And you could do those in one query, and then your resolution could be just getting that user from an internal cache that you built up or something like that. There are already libraries that exist for this, for example, that Shopify wrote called GraphQL Batch that handles batching together requests like this. So in the last presentation I gave, I actually showed something very similar to this where I was doing n+1 queries. And then by just kind of using this batching library, this was reduced to as many queries as it should be, which is technically like 2, right? But we're not going to need to like pay too much of attention to that right now. But the query that got sent, what's very interesting here is, in the end, GraphQL speaks HTTP. It doesn't have to speak HTTP. It can speak pretty much any other format, but standard is based on HTTP. And it's just based on having a single endpoint. And that single endpoint accepts a post queries, and it accepts a get in the case of introspection queries. And then the post itself, the post body, has a query variable, and then it has a variables variable, and whatever else you want to send with it, right? And that query is then run through the GraphQL query parser, and it gets resolved. And what you get back out of it is JSON. That's the interface to GraphQL essentially, right? You get a query in, it does a lot of black box stuff to parse the query and take it apart, and then it runs your resolvers. And in the case of like the JavaScript library, for example, which was the original implementation of GraphQL that Facebook released, that wasn't their internal implementation. Are just anonymous functions that you're saying, for this field, run this function, for this field, run this function, things like that. What's cool is, as you resolve data, it doesn't necessarily have to always be hitting your database. It could be hitting an outside API. It could be hitting a whole nother data store. So for votes, for example, I could have stored all that data in Redis. And in my GraphQL resolver, I could have queried Redis directly and not have had to gone through Active Record or anything like that. So we see some of the cool stuff about querying. We see that it can be really dynamic. It can be really interesting. And like even in this case, for example, we can say, give me the author and give me their username. And yeah, this could go forever. Right now that I have the author, I can say, give me their posts, etc. It can be cyclical down to a max. And you can specify these kind of things. You can specify depth, all these kind of things. Let's get back to here. So now we kind of understand how this query root object ties to the top level of the graph that we were querying. We were querying into this specific posts field. And so let's paginate it, right? So let's do that right now. Pagination capabilities to this. I'm going to need to accept an argument, and I'm probably going to need to accept 2 arguments. And I'm going to say limit, and we're going to say the types. It's an int, a offset. And now pagination here can be anything you want. So in the case of this, I'm using limit and offset because it's simple. Map it directly to Rails active record calls, but it could be a cursor. For example, in the case of constantly updating data, it could be page number. If you're using something like Kaminari or will paginate, which will automatically translate a page number into limits and offsets, I could just say, give me page 1, give me page 2, give me page 3, things like that. But we're not doing that right now. So it accepts limit and offset, and we have those args. So let's take that out of the object inside of the resolver, which is going to run at the time that it's resolving all this data. Grab that. And then we're going to say, what is it? Is it literally limit?
I think it is. Yeah, I think it is.
Yep. And then is it literally offset?
Rose should be fun enough to do that.
Let's see what it does. But we can find out right now. And let's make it so that these aren't mandatory. And let's make it only paginate if we passed in these variables. So if limit or offset. Now, let's make them have defaults. Easy. The limit will be 20 if 1 wasn't provided. Offset will be 0 if 1 wasn't provided. Is it post to limit?
No, keep going.
All right, so then let's see. If I did this right, which I might not have, right? We should be able to not have to paginate initially and only get 20 back. Let's see. Is this 20 records? Yep, it's only 20 records. And let's look at the query itself. We can see right here that it received what I wanted. And then we can see right here that the limit is set to whatever the first argument of this 20 in this particular case, right? And it loads, oh, it's loading 1 user because I hard-coded the current user. This is fun, right? I didn't want to have to deal with authentication. So literally in my application controller, current user is like user.first. Right, check it out. Boom, user.first. Yeah, that's the best kind of authentication. You know always who's authenticating, right? So now that we are accepting these arguments, limit and offset, we can actually then start to add some variables here. And so let's say post limit is, I don't know, 10. Add is 10. And there it is. We added pagination to a GraphQL response. Very simple. It could have been done just with normal, you know, like if you're having static data essentially and you use pages, you could do page. And it could translate to Kaminari or something like that very easily inside of the resolution block. A lot of us in our apps tend to have these libraries that help us do these kind of little things. And we're used to getting a page from a query parameter of a call from HTML, for example, but it could easily be a query parameter that's arriving through a GraphQL query. So yeah, we just added pagination. So that's one live coding success, right? We get the last half, things like that, or the last 10. What would be next? Let's look at mutations. So this is an interesting part of GraphQL, and it's a very important part because just having read-only queries doesn't matter. You need to be able to mutate the data. You need to be able to do interesting things with the data. And the way that GraphQL handles mutations is you define a mutation root. And in this case, our mutation root looks like this. It's all of this in here. And we're saying it's, you know, named mutation, and it has a field, and the fields are very much like what it looked like for the query root, except you call these fields, what's expected to happen is data enters and it gets resolved, and then you get a type back. So in this case, for example, add post, I can call on the mutation root, and it's very much like RPC. Some people have issues with that, but at the same time, some people are very happy with it because rather than trying to fit all of your mutation of your data model into RESTfulness, into being RESTful, into figuring out whether it's a post or a put, I know that myself, I've gone through situations where I'm like wondering whether should be a collection on the end of a singular object, or whether it should be a non-resourceful route, or whether it should be a votes controller that accepts a post ID. There's so many flavors and ways of doing this, it's really painful. And what you get here is you get to define exactly what your method, so these are function names that you're defining these fields as. And you're saying, this is what I expect you to give me, and this is get back. And the cool thing is that data that you get back, it's a resolved GraphQL object type. So you can say add post mutation, and this add post mutation is expected to return a post type. Because it returns a post type, we're able to then specify when you return to me the post type, what are the fields of that object that I want back. So I could do a mutation and add a post and say I only want the ID back, and make a post and say I want all of these other fields back, right? It's up to me as the query writer, as the person providing the GraphQL API, the query, what I want back and what the shape of my data should be. So in this case, it's add a new post. Its argument is a thing called post, and we're specifying that it's a post input type. And this is a special type, and that's defined right here. And a post input type in this case is just a complex type, right? Instead of passing a single value like an int or passing just a couple of strings, we're saying I basically need an object. I need you to give me an object of stuff. And this object is going to have a title and have a description. And when that is all done and I get all that data, and that's cool because by saying the type of the object that you expect first when you're first doing the mutation, if the data that's coming in doesn't satisfy those requirements, it will fail before you even try to run your resolution. A little bit of like static type checking. It's useful in that sense, right? You can be a little bit more strict about your data requirements, about what you need. When we get to the resolver, we have a post in the arguments, and that post is going to have a title, URL, description. And in this case, the context, so if we look at the controller where we're actually running all these queries from, it's just a Rails controller that I've made an action called query, and this action accepts get and post requests. We can look at the routes for that as well. So I'm basically saying anything that goes to /graph it's going to go to the query action, right? Simple, normal Rails stuff, easy peasy. And so what happens is we take from the query parameters, we take a parameter called query. That's going to be the GraphQL query. And this is a standard. All GraphQL APIs, all of them, accept a variable, a query parameter named query, and they accept another parameter named variables. It's a standard. It's in the specification. It has to be that way, but it's good. That kind of standardization provides us a kind of a bedrock to build on top of. So once we have that, I have my schema object, which is an object that I actually define in where we're looking at all the types. It's just a really simple object. But on that schema, I'm saying execute the query that came in. I'm passing in any variables that came in, and then I'm saying of the context, give me the current user. That current user is coming from my Rails context. Controller, I defined a current user method. That's what's being called right here. And that's now being passed into the GraphQL query parser, and it's being passed around within that context object. That's cool because at any point in time in any of your fields, anywhere in your entire graph, you could reach into that context object and you could say, is this current user an admin? Does this current user have permission to show this thing? Does this current user have permission to view this subfield, et cetera, et cetera? If you return nil from any of those resolutions, and that's perfectly acceptable. That's how you do, what is it? It's how you do authorization and authentication within your GraphQL APIs, essentially. If I actually wanted to do real authentication, I could have added a before action. It says like only logged in users should even be able to get to this, for example, right? That's one kind of authentication.
So it loads the whole user?
Yeah, it's a user object. In the case of Shopify, for example, they felt that their APIs, they had one GraphQL API that needed a certain amount of permission and another GraphQL API that they didn't want to mash them together and have to deal with these permission checking in between. For example, a shop owner and a customer, right? They're very different views of the same data. So what they did is they actually created two APIs. So they have two parallel, not necessarily parallel, but two GraphQL APIs. And at the top level, as the queries come in, they're able to check user a store owner or are they a customer, right? And don't even let them query in the first place if they're not of a certain permission. So there's kind of how you handle authorization and authentication. Once we execute the query, we get a result and we just return that JSON. It's really simple in reality. The magic is happening kind of in this execute call where it's resolving every field. So we get back to our schema. We're going to look at where we ask for the context, and we're going to see that basically on that user, this is just Rails stuff. Current user .post .create, and we're passing in the title, the URL, and the description. Very simple stuff, and we can actually run this. And what we have to do in this particular case is it's no longer considered a query, and this is cool because queries and mutations at the same time as necessary. You can pass in any shape of data that you want. In this case, we're going to say at the mutation at the root level, we're going to run a query called add post, and that query accepts a post. And we're going to start to pass in as variables instead. And in graphical, query variables are just JSON that get passed in through the variables object instead of embedded in the query itself. So we're going to make some JSON. So we're going to say post, let's say title, awesome. No, let's do something else. SA coders. Yeah, live coding. We're going to say URL is, who knows what the URL for this space is? So we're going to say Google. Google knows. And we're going to say, what is it? Description, which is a necessary field. This, we're going to say, woo. Okay, so that's the query variables that we're going to pass in. And GraphQL has a special syntax when you're trying to map variables from the JSON variables data structure to somewhere in the query itself. So we have to specify that we want to have this variable kind of mapped into the query. And so we're just going to use another name, same name basically. And we're going to say something called post is of a post input type. We can say post. And we know that the return type for this call type, it's going to give me a post back. And we're all used to that in our RESTful stuff. We're all used to saying post.create or post/create, and you get like a post JSON back, or you go to the post show page or things like that. But this is completely up to you what you return back, right? It's completely up to you what you do in this particular case. But we know that we're going to get a post, and it's going to have a title, and it's going to have a user, and all that good stuff. Let's call author. And so we're going to say, okay, and this is the query that you need to satisfy after you create that object, after you do that mutation. We're going to run that, and there, I made a new post. That's just created in the database, and this is the data that it got back. And what's more interesting here is, again, even though I did a mutation, even though I created something in the database, I'm still in control of exactly the data that I want back from you. I would only have specified that I want the ID back if I don't care, if I only care that the thing succeeded. I could even specify that I don't want anything back in this particular case. We can make another one. There's 45, 46. It's very fast. You can see that it's inserting into posts.
Well, what would happen on that mutation on the query variables? Are all those three required?
They are required.
What if you took one out? Like, would it error here in graphical?
I think it would return an error. That's the other thing. Within GraphQL, errors that occur within the query parser, or while trying to resolve or trying to do mutations, they're also standardized. So no more of like defining exactly the shape of how you return errors from your RESTful API, which everybody does it differently. We all know that we've done it differently.
How do I create this? Is errors data, then data errors?
Exactly. And you have to deal with your envelopes, you have to deal with all this stuff. It's always the same. It always comes with some extra introspection data so that you can know exactly what's going on, exactly where things went wrong. Now, this is important here because as we move on to, for example, messing around with the Apollo client, which I should already be moving on to, it's able to give us good responses for its responses. It's able to tell us this is the error that happened at the database, at the endpoint, right? At this particular place for this particular reason. And so in this case, it said description. It expected the value not to be null, so it expected me to give a description.
So on a bad call, it gives you errors. Like, are you able to show normally, like whenever you do a regular API, you see a success. You have your data, and then you see success. Is there a way to kind of show that?
So all you check it out. That's it.
So just a success.
After a mutation level, either a data key, which will have the return data, or an errors key. That's how you differentiate. You just do a mutation. Did it have errors at the top level response? If so, then I know that it failed, right? Or for whatever reason. And it could have been your own internal validation. So I think in this particular case, if I'm on one of these fields, which I don't, it would catch that from the library itself, and it would turn that active record validation error into an error that looked good in this GraphQL output, for example. Yeah, so that's mutations. Now, do we want to write a mutation maybe to add a comment? And then what's cool is we know we just did that mutation. And we go back, excuse me, and we look at the posts. Here are the posts that we just made. All right. I need to refresh because there it is. I say coders, these are the posts we just made. There's the author, all the posts that this person's made because it's the first user and it's really easy. Right? I forgot to include the score. So I could also grab the score of any post that I want to make, for example, because that's a field that I specified. Now, what's interesting about getting the score is when it gets the score, it's actually querying the votes, and it's tabulating vote scores based on whether those tables have different votes that are either up, meaning positive one, or down, meaning a negative one. So it does a quick tabulation and just reduces across that.
So it's calculating that on the fly, is what you're saying?
Yeah, it's gross, but it is. Because why not, right? We all want to do it the easiest way first. So at this point in time, we can move into trying to use the Apollo client really quickly and just being able to query for posts and showing them in a React Native app. Or I can try to create a mutation that does the upvote. Yeah?
That's my vote. Everyone else can vote on anything else.
Okay, so I made a quick React Native application.
I don't care. I really don't care. Someone else wants to see that.
And it's
React Native will be awesome.
So here, let me get into it. I put it in here. Here it is. So within React Native, you have two top level entry points. And I'll turn off linter. Right, points. And this is all ES6 JavaScript. It's very new. You have to deal with like imports, and you have to deal with it's ES7, ES6. So in this particular case, I named it Reddit app because it's a terrible name because the underscore can't be seen, but it doesn't matter. So anyway, when this top level React component renders, it's going to have a view and it's going to include some styles and all this other stuff. And this is like React Native stuff. What's cool about React Native, for example, is that all styling is done using Flexbox and using CSS. Example, to show a list of stuff, you say display flex, and then you tell it, how you want it to flex, right? Whether you want one of them to be bigger, smaller, so many things. And it's registering the app. And so we'll actually run it right now. So I think it's run iOS, and yeah, that'll start up. And then we're going to get rid of all this. We're going to empty it out. Well, let's keep the container. And we will do this on the fly. I did not prepare any of this part, so this is going to be fun. And I'm going to have to look in the Apollo docs, but I think I can do this in like
Do you just use the React starter pack from React Native?
Yes.
Or do you use some?
So Exponent is another big one that exists, right? Exponent is interesting because they basically try to abstract you away from all the underlying native stuff in a much different way. So React Native is like they give you an Android app and they give you an iOS app, like if you've made it in Xcode, for example. And then those apps, you can look at the code that is calling into the React Native runtime and starting up the React Native JS runtime and kind of deferring to that. They wrote their own versions of that, and they're calling into the React Native runtime, which is then where your code kind of starts running. You never go further down than a certain level. A couple of things that buys you easier deployment. It buys you some native components that they wrote themselves that integrate really well. But at the same time, everything they do is open source, and it's not that difficult.
Just get expo.io.
Yeah, it's called Exponent, React Native Exponent. Like for me personally, if I'm going to write a React Native app, I'll do it like this from the metal. You get the React Native CLI, npm install, and you just say React Native init, and you name it something, and you just go. We're like, I'm used to iOS. I'm used to Android a little bit. So if necessary to modify the underlying Xcode project, I feel comfortable doing that. So that's where I would go. Let's really quickly get into this. We're gonna have to get a list view again. Hey, but this is testable at least. This is much more testable than, in my opinion, an Xcode project. Like, because it's easier to test this code using Jest and things like that. Let's get Apollo going. So we don't want to integrate Redux with it. We just want to get it on.
I have a question while
go
you're
for
it. Are there any alternatives to Apollo? I know Apollo's like. Are there any of the good ones?
So Apollo is the best I've seen, right? Everything else is trying, but nothing is as feature complete as Apollo. Apollo is a GraphQL client. Now, GraphQL is a standard. All the clients are writing to the same standard. They're all, like passing in query parameters the same way. They're all making sure that queries are of a specific structure. They're all knowing what kind of shape the data has when it comes back, whether it has errors or whether it has data, all that kind of stuff. So as long as they've stuck to the spec, they're all generally the same. But Apollo goes above and beyond in the sense that when it's an app, they have their own Redux store, for example, where you don't have to use that. But what they're doing is they're using it to cache the results of calls, right? So as you start to query around in your data set, some of those queries are going to be completed immediately because it was cached on the client, for example, by Apollo for you. Really nice little things like that. They add a lot of integration into whatever you're using it with. So for example, there's an Angular client for Apollo into Angular's lifecycle. There's the iOS client, which is going to let you take a GraphQL object structure and output it into static Swift objects so that you can use them with correct type checking on iOS, things like that. It's really useful. I think Apollo is definitely the best thing there is right now. So we're going to do the React Native thing. We're going to do it really fast. Let's see if I can do this. All right. So let's just grab all this junk. And we'll do that. And then we're going to have a provider. And then we'll make a client right now. Give me a second. Apollo provider.
No, but I was gonna go to the potty while he was doing
Go for it. Something good. And then I got to get a list view, and I think it's called a React Native. That React Native docs are really good. Oh, I'm not even on the Wi-Fi. What is it? What's the password?
1218 capital C
Yeah. So as soon as I get on, we'll get to the React Native app docs. There it is. So list view, you need to use a constructor. You need to do something. You need to create a data source. But it makes sense, the data source and things like that. It reminds me a lot of getting a data source in like an iOS list, like a collection view and stuff. I don't know if I need to do this with Apollo yet. Let's go back to the Apollo docs, and we made an Apollo provider, and then we'll look at some examples. Let's look at the GitHub API example. Just we'll go here. Nope, that's not that. Right here. So in this case, they're getting a scroll view in Navigator iOS. They're getting their GraphQL stuff. There it is. This is what we need. Create network interface. All the time. So we're gonna const interface create network interface. And what this is doing is GraphQL doesn't necessarily have to always be hitting the network. It was made to also be able to query static data structures. Interface that's a static data structure interface. And your graph could literally be like a deeply nested JSON of stuff. And it would be able to go into that JSON data and like query it using GraphQL queries. And we're going to say that the interface points to localhost.
Oh, like, what's the? Oh, sorry.
3000.
That was my phone.
Graph. And we're going to say, here we go, client. The const client equals new Apollo client. And network interface is that. And we should have named it network interface because then we get object destructuring. So what's typically happening here in ES7, when you, in an object like this, define something with just a name, it destructures it into a key with that variable as the value. But you only have to write that. That's really nice. Taking a swig of beer. So now we have a client. We have all that stuff. When we get to the provider, we pass the client into the provider. Okay. Have hooked all that stuff up. Now we just need to get a query into another thing. So what we're going to do here is we're going to stop this for a second, and we're going to make another class, and we're going to call it post list. I'm going to say because it's probably going to use a list view. I'm going to say render, but it doesn't have to actually. Now that I think about it, and I know that we GraphQL Ruby or we added the GraphQL tag library, which gives us an interesting tag. It gives us a tag that allows us to create a higher order component that maps a GraphQL query to a subcomponent, very much like what Redux's Connect does, things like that. So we're going to want to import GQL from that. I think, yeah, right there. GQL from GraphQL tag.
Why is it tag? What does that mean?
So in this particular case, the library is called dash tag because it's technically a JSX markup tag, right? That's the idea here. It's a higher order component that's giving us a wrapped component that holds that query. So then we now map the query to the thing. Where is it? I'll get to this, guys. I'll get to it. All right, let's go back to the docs. Cool. See, and this is post list. Here we go. So data, loading, posts. So in this particular case, what Apollo does is it gives you some niceties. When it's actually doing its queries, it doesn't just return the data, it also returns the state of whether it's loading or not. So when we use this GraphQL tag and we do a query with Apollo, we're going to be able to know from Apollo whether it's loading the data right now or not. And that gives us the ability to add a loading indicator in the UI, things like that, when we're using Apollo with React in this particular case. So this is the GraphQL tag, I believe. GraphQL. So we'll import that too. All this junk we're importing. And we will wrap this list right now before, let's call it connected post list. Right, and we'll say it equals GraphQL, and then that's what GQL is. GQL is actually a query parser. So it's going to parse this query that we're going to put into it. And it's passed as a second parameter, the list itself that we want to extend. Okay. So this is creating a higher order component, this part right here. And the query that we want to pass is going to be exactly what we wrote earlier. And we're actually going to get GraphQL syntax highlighting and stuff in here. So we're going to call this, and it's going to be posts, and we'll say limit is 30. Let's get 30 at a time. And we're going to say we want the ID, we want the description.
How are you getting the syntax highlighting in there?
That's just provided by Babel when you do a GQL tag. Yeah.
So
this is not JavaScript. This is GraphQL.
So you don't have to comma separate those?
GraphQL.
No. Yeah, this is a GraphQL query. You have to think about like its own language, like an SQL query. It's its own query structure. It has a specification.
Okay.
Yeah.
I thought those were comma separated too.
And let's actually give this one a name. We'll call it get post. Okay, so now that's connected. Now this query is connected to this post list, but this post list isn't accepting anything yet. Let's see. And then we could have made it a single thing. Real gross and ugly, but let's do that. And what we're going to do is we're going to use a single function. Like, what do they call it? A single function.
Anonymous?
No. So just not exactly what they're doing. Now, in React, you can define a React component as either a class that has a render function and has a constructor and has all that stuff, or you can define it as a first class function. That's what it is. And this first class function is basically the render method, and it gets past the props that were passed to that. It doesn't have state, exactly.
Whereas classes have state.
Exactly, or classes can have state. You don't have to. And in this particular case, what's cool here is the management of the state is happening at the higher order component. So Apollo is handling whether loading is true or false. Apollo is handling whether data has data in it or not, or whether there's errors, things like that. So all we have to worry about is getting that data back and rendering it in this particular, method. Yeah. I should have named that a function like this. Okay, so and we say if loading, we're going to do exactly what they're doing basically. We're going to return a view. We're going to say the style. I'm almost done. Style.
None of this will have a syntax error.
Loading view. You'd be surprised. It's going to be pretty awesome. Yeah. And I could have used like a iOS style, like a loading indicator. I could have pulled that in, things like that. But we're going to say else if it's not loading. And this is the beauty of React, is it just re-renders over and over again when state changes or when new props come in. So when the higher component changes the props, it re-renders this component. And otherwise, we're going to say view style equals styles.container, and let's call it list container, post list container. Okay. And I don't know right now. We'll just render a view for each one of them. So we'll say, like they do post map. And you say post, and then you pass it on this function, and then you open up that function in there. That's what we're returning there. We're going to return another view, and that view is going to contain some other data. No, I don't want to deal with that right now. Give me a second. I can figure it out. But give me a second. I'm going to say inside of here is the post dot title, which we know that we requested in this query. And we're going to also say that let's do another text box, and that's the post dot description. And we can style all this right now, but let's see if we actually get any data back when we run this. And that should be it. So now we can use post list, and let's go to where they're using their post list, for example, and they're just rendering at the very top. So let's do the same thing. Well, it's connected post list now that we've connected it. All right, see what happens.
Where did you define like the URL?
Like the client right here. So I create a network interface using the create network interface method from Apollo client, and then I pass that into the client itself, and then the client under all this stuff in the main render method of the main, like the root essentially, it's passed into the provider. So now the provider what the provider does is it stores the client on the context. And so any subcomponents that are rendered are able to access that context and therefore access that client. And our components never necessarily have to access that client, but this connected component that I'm making from this GraphQL tag does. So what it does is it accesses the client that's available on the higher order component. It takes this query, it runs it, and then as soon as it renders, basically, and then I'm able to know what happened or not. So let's see what's happening. Does it have errors? Show me, show me. Reload. All right, here we go. Duplicate declaration of app registry. What? Oh, I see. I grabbed an extra. Yep. There we go. Follow client GraphQL is not a function. I probably grabbed this wrong. Is it named different? Give me 1 second to figure this out. No. Oh, it's from React Apollo. My bad. It's a whole different library. This is the library that connects Apollo to React. So
you have React Apollo on 19.
Oh, perfect. See, this is mob programming. You're the mob. Yeah. There you go. Post list, the value must return. Oh, I didn't return from inside here.
I think the thing to note is the error changes. Whenever the error changes, you know you're on the right path.
Should let Nick figure one out.
Unexpected token on line 26. Why is this unexpected? No, no, it's definitely not it.
Something's not closed.
We can do this. We can do this. We're almost done here.
Line 26, what? 4?
26.4.
Take your time.
26.
There's a lot of code you typed in.
1, 2, 3, 4. It's at this if.
Can you-
Oh,
you
because
can't
it's inside
return-
of the return. You can't return and
Oh,
if. Oops. So the returns have to be in here.
It's right there.
Yep. See, we're learning, everybody.
I had no idea you can do that.
Yeah.
Yeah,
Because that's the
we-
render. The view
Yeah.
is the render. Part of React.
All right. So then let's unindent this. There we go. This should actually work now.
Usually try to say that after you hit enter.
Error. Geez, this one got bad.
Confucius said, "Do not talk shit before I say it." We would always play ping pong. We would always talk trash. And my buddy would always say that because I would talk trash and then I would miss the next move. So Confucius said.
All right. And what I'm going to do now is little GraphQL magic or React Native magic. You stop the whole thing. You do it again. Run iOS. Here we go. Let's see what it gives me this time. So this should be getting pretty good now.
So can you explain that the connected post list again?
This part?
Yeah.
Okay. So what's going to happen here is this is from a React Native Apollo, right? A React Apollo, and it's going to wrap the component that I input, right? The argument in, right? So post list. It's going to wrap it, and it's going to have a component will mount, right? Or a React Native lifecycle hook. And when that lifecycle hook gets run and the component's about to mount, it then takes this query that I'm passing in, that query against the client, and then it's going to take that data and it's going to send it down into props. But before that data comes back, it already has sent props to the subcomponent that don't include the data. They include that the data is loading.
It's loading. Okay.
Yeah. And all this stuff is really well documented.
And how did you know that it was gonna, like, how do you know that it's gonna pass it in as like loading? Like, how do you know what props it's gonna pass in?
Because the Apollo client is really well done.
It's just documented.
Yeah, it's super well documented.
Okay.
Yeah.
All right.
So then we got to figure out what this junk is. Ugh,
Was the error?
it's a big ass error. From update component, so somewhere in here, somewhere in trying to render. Wait. It's from Apollo. Call function return Q. Am I missing something in Apollo itself? Stuff.
So you didn't color the application red, right?
No. Well, yes.
These are
yes,
actually your posts.
And here you get your
all done. All done. Components. So somewhere in trying to create a component, it failed. Somewhere in here.
red screen of death. No.
Blue. Loading and posts.
I actually saw a TED talk, like they were talking about Airbnb. Like, I think the red screen of death.
React Native.
Yeah, that's what they call it. Connected post list, Apollo provider. I'm not going to give up. We're going to stay here all night.
Does it have something to do with the map you're rendering?
It's possible. Let me pull some stuff out. Let's see what happens.
And also
Yeah, does that 32 return? It's after the view, okay.
No.
I thought maybe it was closing brace.
You know what I found in like React Native? It's just like a text can't be next to a text or stuff like that.
Oh, you have to wrap the.
It's like code on 25.
Which is what I did.
You can't.
Well, no, you can, right? Let's try an empty view then. Oh, so something in React Apollo. Interesting. So in this connected post list. All right, let's look at what's going on.
Hey, sorry, what did you do to like double click that and all of a sudden it was like popped up, little pop up
Oh,
in GitHub?
this? So I use Grammarly, and Grammarly provides a thing now. If you double click, you get antonyms and synonyms for words.
Okay.
Yeah, it's useful, super useful.
How did that help you?
In this particular case, it didn't help at all.
Oh, you
Oh.
just happened
It
I was
doesn't.
like, man, that's a GitHub page I had not seen.
Maybe my query was bad. Here, hold on.
Yes.
This query, I'm pretty sure I ran exactly this query. The good thing is we can just try it out against the real data sets.
Oh.
And it's a good query, right? So that's an interesting thing. So it's not the query, it's somewhere in here.
Is it hitting your server?
Yeah, let me check it right now. Okay. Boosh. And then
On React Native, you run your console.log.
oh, there it is. It did hit the server. Invalid authenticity token. We all know what happened there. How do you skip the prepends and skip the? Yeah. Jeez, we all know what that was. Once you've been doing APIs forever.
You're not in the same folder?
Huh?
You're not in the same folder?
Well, it's coming from the simulator, I think, and it doesn't have a CSRF token when it's actually hitting the API. Now, the graphical thing to do queries, that's being rendered by Rails, so it does have a CSRF token.
Gotcha.
Right? So what is it? It's skip. Before action.
CSRF.
Rails skip
No.
CSRF. Once I do this, it's gonna work. It's just dumb error. Jeez. Protect from forgery. No, skip before action. Verify authenticity token. Okay.
Yeah.
Been through this a lot. All right.
What?
No, it's something.
There you go. See, no error is better than no error. Oh.
So it looked like it's
White's
returning the
better than
data.
red.
It's not really-
You know what? I didn't style it at all.
Oh no, you took
let's-
everything off already.
Exactly. No, it's there. It just isn't styled. So now we need to add some styling.
Oh yeah.
So connected post list is styled as loading view or post list container. So let's do that. So let's do loading view first, and we'll say flex 1, and we'll say align center, and that will align the text that I added that says loading. All right, so we'll see that no matter what first. And this is all Flexbox stuff.
That's pretty awesome.
So it should say loading for a second, but it doesn't, of course. You know how it goes.
It's super fast.
Yeah. Let's just say gray. Is this working at all? Not at all. Did I use the right thing? Loading view. If loading. Oh, hey everybody.
Return view.
Yep. Look at that. That is hitting a GraphQL API. Even though it's ugly and all that, it's there. And look, we didn't get an ID, or we did get an ID, so we can start using the IDs as keys. Post ID, and now it's going to stop complaining about the iterator, and then we could start to add styling and all this good stuff. And we will say we have to give each one of those tags a thing. Container first. Sorry, give me one more second. And we'll say margin top 20, and that'll pull it down. And I could actually be doing this hot programming it or whatever, but hot reloading. And then we will have to give each one of these a style, and we'll say style is styles post list item. Look real nice. And we're going to say margin horizontal. Adds a couple things that are just its own.
Yeah, I haven't seen
And
that.
we're going to say border. Forget how it goes. Well, let's just change the background color of the post list container. That'll be easy. We'll leave the background color of these white. Boom. But they need bottom margin. So they need margin bottom. Let's say 20. This will be it. Individual items. There we go. And we'll put it in a scroll view so they can scroll, and we're done. I'll be done now. I'm tired of this too. Native application. It's really fun, actually. And it's surprisingly simple. Really well. And it's really fast.
I've seen people struggle with iOS.
Here we go. To the scroll view now. Yeah.
Well done.
There we go. We made a React Native application hitting a GraphQL API that we programmed right here. All right.
Any questions, guys?
Yes, please. Any questions?
It'd be cool to see your code.
I hope this.
I'll put it up ASAP. I have it all just sitting in one folder, so I'll
Oh, okay.
throw it all together.
It's pretty good.
I'll put the link. I'll add a comment to the Meetup page.
Sweet.
Alrighty. Any other questions? Anything else?
No, I think you covered everything really well.
Good stuff.
Blew me away.
It's really easy to add GraphQL APIs to stuff and start using them piecemeal.
I have a question. I think I kind of understand GraphQL subscriptions, but maybe you talk about what that is.
Not really. So essentially, a subscription type is you open a WebSocket to a particular place or some kind of streaming API, and then you specify that you want to receive subscription events or subscriptions of a certain type back from the API, and it's just handling real-time stuff. So now, like for example, let's say we have this post, right, and we know that people are adding them all the time, and we want to have a real-time feed of them coming in. You can then specify a subscription type field that you can say, okay, I'm subscribed to this now, and everything that matches this query return to me back. You can get real-time data in the shape that you want as it's being created using the subscription query stuff. It's hard though because not a lot of APIs support it fully yet, and you have to have a concurrent like language in the first place to be able to do it well. So like Elixir is doing it, in Absinthe, for example, because they just start up a process and they can stream whatever that matches a query type.
So it's like you could create a subscription to this particular query.
Yeah.
That's what I understand, and like it's just pushing you updates as
Yeah, as soon as new data comes in that matches those queries, from the back end, you have to tell the query engine essentially that data of this type. And then it goes and it queries for data of that type against your subscription that you're set up with. The query that you passed in your subscription. So the query that you passed in is dynamic, right? So it could be that you only want the ID and the title, and someone else wants all the data, for example. It's going to check to see if one of this new type came in, query against that type to then strip it down to the data that you need, basically. It's really awesome. And it's going to be you're saving tons of bandwidth. Like, who needs all of the data? You don't, in reality. Sometimes you just want to be informed that a new ID exists, subscribe to. For other people, it might be that their interface is like Twitter, and they're constantly wanting to append a new item at the top that already includes all the data and all the sub data that's necessary to render that item, without having to go back and fetch extra data, for example. Yeah. Cool.